There we go. We missed the beginning, but there we go. Right, start a quick prayer. Holy name. Give you the praise and honor for all the things that I have in my life, my achievements that I got in my life. And I thank you, Lord, for all these souls that you bring before me today, and also these souls still alive and well in this time. They've not passed on to the next place, and they are still here, still have their chance to be saved. So, Father, Lord, I pray you draw them into your Son, Lord Jesus Christ, and help them know that the only way and the truth and the life is Jesus Christ. I also pray that we have a good time today, have a fun stream, but also achieve the things we're set out to achieve. And I pray that every one of these people know that your time is coming. We don't know the day nor the hour, but we know that we're in this season and you're coming back soon. So I pray that my viewers wake up to that. In the mighty name of Jesus, we pray. Amen. Cool. So let's go. So people who are watching back on YouTube, basically I did an intro and I recorded it late. So we're doing procedural grass inspired by Ghost of Tsushima. We've got we're getting to the point where filled with grass. So in scene so in the grass blade vertex shader, we also need to pass into the mesh. It's a layer buffer. So this is how the code works. This is the pixel shader. So we don't use a depth buffer and a color buffer standard like attachments. We do it manually using the pixel interlocked thing, and we do 4 layers basically. It's just a sorted front to back 4 layers of buffer stored in the RGBA components. So basically it's a visibility buffer. If you know what one of those things are, if you don't, give it a search. It's really cool. You basically store an object ID per pixel, and then in the scene shading pass, or in the deferred shading pass, you can pick up the object ID and the depth and work out every other parameter you need to do shading. It's really cool. So we've got 4 layers for in order independent transparency. Now, the grass blade. We need to figure out what the triangle ref and that is. So I was thinking, yeah, we'll do a triangle instance and a triangle set up so it can get, so our triangle ref, it now needs a couple more bits, unfortunately. So we need to take away from some other ones. So I've already done 12 bits for the instance anyway. There's actually already a couple of bits hanging around. It's kind of cool. So we've got, at the moment, let's just use 4 bits for a kind. No. Let's do unused bits. So we've got unused bits will be 2, and we want to use let's just use 1 bit for now. This would be the kind. And so that would be a enum. Oh crap! This is the database file, for crying out loud. Right. Well, hang on a minute. No. This with 3 bits and 1 bit for the kind. So this would be an object kind. Well, triangle instance ref what's the kind? Basically. So one will be a mesh, the other will be a grass. I don't know if we'll do anything else. Maybe. Yeah, we'll just see as we go, right? So mesh. The other be grass blade. Cool. So that'll go here like this. 1 bit. Use for that. Hey there, Mystic Still. How's it going, sir? God bless you. How you doing? Question about the pipeline generation. I recently switched to Slang for shaders. Cool. And I found GSL Spivvy Reflect. It's a nice library written in C and for doing shader reflection in Spivvy files. So I don't use any shader reflection. So I guess the question is, why do you think you need shader reflection? So I use bindless for basically everything. And so if it's for descriptors you're trying to solve the problem for, the answer is just use bindless. But oh yeah, I'll see what your answer is first. We can talk more about it. Right, so for the mesh one, we're obviously output mesh in there, yeah? So the other thing we need to do from the vertex shader is, so one instance index so we can know which grass blade, but we want to know which triangle on there. So we're doing a strip, triangle strip. So how would you go from a vertex index to a triangle index using a vertex strip? Can you even do that? I don't know if you can. Let's start drawing. So here's our grass blade. So 1, 2. Oh, okay. 1, 2, 3, 4. You know what? It's complete. The way it's done I've done the things is wrong. But anyway, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, something like that. 1, 2. Yeah, so you can't get a face, a triangle ID from a vertex because they've got shared. Yeah, so we're gonna need. So this is a problem with it. We're gonna have to duplicate the. No, because there was that extension we can use. Yes, I'm using banners too. I'm trying to solve the descriptor layouts. Yeah, so with descriptor layouts, you just need one anyway, right? So if you're doing bindless, you can. Something like this, yeah. I think this is the only one we have. Yeah. So you can, do you want to screenshot that? So basically, you go over. Oh, the vertex input stuff. Right. Yeah, so basically don't use vertex buffers. They probably offer on desktop hardware very little benefit, if any. I think on AMD they basically offer none, and then on Nvidia it's probably just it's so negligible it doesn't really matter. You'll much prefer the flexibility, so just have a storage buffer, store your vertices in there, synchronize it, and just read it manually inside the shader. The other benefit you get is you can do vertex packing in weird ways. You can have a custom uh, bit packed vertex, so you can actually save more bandwidth by packing your vertices better. If you do your own software vertex buffer as well. So yeah, these days GPU memory is just like it's cached and all that, isn't it? I think on mobile phones though, if you're going to be doing vertex buffers, sorry, vertex shaders and that, you're probably better off using vertex buffers, but I don't know that for sure because I don't work on mobile. Yeah, either you do the address thing, either you're doing the pointer, or you're doing an index for a buffer, right? I use indices because I don't want to do pointer support on everything, but and also pointers are like 64 bits. But yeah, you just pass the index or the pointer to the buffer, and then off you go. You use a GeoVertex index to index it, obviously, yeah. And then you don't have to do all that silly stuff in the pipeline, and you can actually change the vertex layout. Like, yeah, you can do all sorts of crazy stuff. You can do indirections, and yeah, there's just so many benefits for not using not putting it in the pipeline. Um, Man, this problem kind of sucks. I was hoping. Yeah, I was hoping to get the primitive ID. Why didn't I do that in the end? Very good point. Primitive ID in the pixel shader, but you have to put a geometry. It's gonna write a whole thing for me, isn't it? Automatically filled. That's what I want. Yeah, let's see if we can make it work. That would be cool. So, what happens if we manage to do this? Bit filled 0, I think it was. So GL primitive ID. What about for Vulkan? Is it primitive index? No, cool. You have to enable geometry shader. I think I already tried to do this. I bet you there's a reason why I didn't do it. Simply using primitive input fragment shading causes significant impact in certain hardware. Primitive web path, okay. Yeah, I'm not really too fussed about it because we might switch to using mesh shaders anyway. So yeah, I don't care about it. So equals I bit filled 0 equal I instance ref. Okay, I think that's what we want. So when it comes to this, we don't really care about setting the triangle index. That'll be set later. Let's initialize to 0, I think. That's a good point. How do you do that, didn't you? Yeah. So from the mesh side of things as well. Okay, so the triangle index is going to be set there. That'd be awesome. Now we shouldn't have to switch out. You know, we can keep using triangle strips basically. That'd be cool. Right, here we go. Let's see if that works. Oh, so it's not doing anything scene shade side. So this is the deferred shading pass. And right, so we get the instance ref. Oh. We need to do triangle ID +1. Hang on a minute. Layer buffer +1. Yep. Okay, so where are we going now? Yep, so in the shading pass, we go over the 4 layers. We also want to grab the kind of so there's a triangle instance kind now. So there'll be a grass blade kind and a mesh kind. So we've got to figure out how to, you know, for now, let's just keep it simple. Let's say switch kind, and we're going to say the mesh kind will do what we've written the code to do, and then the grass blade kind is going to basically render black or something. So it's going all white. Let's render white. So it'll be obvious what it is. And then we can adjust it. Hang on a minute. Right, so obviously we want to do this whole shading pass on the grass blade, but I just want to get something running first, you know? It's been a while since we've seen it run. Here we go. Right, got some compile errors. So the emit grass. So we're just doing it, you know, emitting it through a shader. That way we can do a runtime a lot easier because my Octo reload is not that good. For CPU, it keeps crashing, and that's a problem for future Henry to solve, not present Henry. So segment. Ah, that's a shame. Segment ends. Okay, so what else is a problem? So are we missing from the build script the where's the encoder? We're missing a grass blade. Oh, I've got it here. Anyway, let's deal with that in a minute. Okay, so we're looking for 29. DST coord. Right. Oh yeah, what are you? You're a float 32 times 3 in, yeah. Yeah, so we've got to do so that's a scalar aligned vector. Right, so 32, nothing called segment ends, unfortunately, for some reason. So let's look at that. Oh yeah, because you got to actually set it with one of those long functions. Because it's a packed field. It's been code genned. This one. Oh, 35. Right, what's that saying? Two something, two what? Too few arguments in this guy. Type. Oh, really? Oh, yeah, so what? Oh, yeah, for type safety and all that, I think. Well, kind of. I've not done one of those yet. Yeah, you need to put it in there. So it's one of these types. Did you get the right descriptor array basically, and then it's type checked against the buffer ID that you pass in here. Rightio. Oh, we've got to run. That's good. No, it's not good. I don't think it's done it properly. There's this guy is not rendering yet. The grass layer buffer. This one's not working. Let's see. Yeah. My build system has some bugs, but it's okay for now. We can live with it. So 11. No such field in so it's GPU sorry, grass instances. Yeah, so this is the type error I would get basically. So because we got typed IDs for buffers, it basically says, hey, I cannot find the field name GLSL buffer ID underscore read only underscore in the name of the type because it's a wrapped index structure and we name the field this such that it's type safe. Pretty cool. But yeah, so grass instances, I think that's the one. Yeah, see here's the custom type. There it is. You define them like this, I think, in a macro. But yeah, just getting around the shading languages not having stuff that we want, like, you know, not having built-in support for binderless, basically. Right. Not enough data provided for constructor. Yeah, Z0. 16. Right, we need to vec3 underscore that. Turn into vector3. Sorry, vector2. 23 as a comma there. Cool, so this one's saying it's missing the fragment shader, grass render LBFS. So that's fine because that doesn't actually exist. Instead we're using the mesh one. Get to reuse the fragment shader, which is pretty cool. I'm hoping we can still do that even when we switch to a mesh shader. Cool, so here's our plane. And we're rendering absolutely nothing, unfortunately. I think the controls are the wrong way around. Let me go to the orbit cam thing. It was camera, isn't it? Yeah, so the wire packet. Okay, so nice. Now the next thing we need to do is, so we should be expecting to see a grid of 8x8 grass blades, but we don't. So we can check the object layer. Now we can say, hey, just we want the front channel. And we're seeing, let's do hash, I think. Right, we're just seeing nothing really. It's not really. So first of all, this plane is being drawn with a. It's being drawn with the debug drawing stuff. This is not a mesh. It's just a debug drawn ray traced thing. It comes after this pass that draws on the object layer. Now, oh, that's blinding me right there. Yeah, so it doesn't look like, if we look at the depth image, yeah, it doesn't really look like we get anything rendered. So we pop into render doc now, since we can't figure it out from that. How do I handle, sorry, I didn't see that. How do I handle sample textures? Let's use descriptor heaps. I don't think you need descriptors for these. You still need sample textures, but yeah, use descriptor. They're just bindless, right? So, not sure what you mean exactly, but my GPU API will, when you make an image, it takes in the usage flags. And if you specify it takes a sampled image, then it will make a sampled image descriptor, and it's going to have the same descriptor index for storage and sampled. It does a little bit more complicated things because it does mipmap views, but what else? Yeah, it's a bit of a complicated system, but it's because we want to write to because writing to images from compute shaders, if you've got mipmaps, sucks. You need to have an image view for each MIP level that you want to write to. So if you specify MIP levels, then specify this MIP map views is going to basically, inside the descriptor set, it's going to allocate a range of, it's going to allocate a range from within that descriptor set where, say, these three, this will be the sample images or sampled images we're going to call them, and then storage images. So say if it allocates these three here, 1 and 2. So these 1s and 2s will store MIP views of this one here basically, and it allocates a range next to each other. So all you have to do is pass around the index, which gets you to here, which is 2, right? And then in the shader, you basically offset by the MIP level to get the right descriptor. It's a bit complicated code to get this to work inside my GPU API, but it works and it's great, but it's a bit fiddly because you can't write to a MIP level from a shader. But yeah, sampled images, they're just mirrored alongside the storage images, and if they don't exist, they just, yeah, are not stored in there, but the slots are still allocated. Oh, the combined sampler image. No. Just make those separate, because then you get control on the which sampler to use. Yeah, don't use the combined one. I'm currently pushing the index for the texture. Nice. You do realize you can use the push constants from the fragment shader as well, you know? You can use them in both stages, so you don't have to pass it through a vertex attribute. Yeah, you might want to do that if you're doing multiple textures per mesh. But then it'll probably be stored in different places anyway. Yeah, so in your push like, I know here's my fragment shader here, see? I've got def PC, so push constant, and here it is. So all this does is just deal with the stupid syntax, which is GLSL, and does all of that. Right. And then I can do my PC macro where it just gets it. I guess you can screenshot that if you're using GLSL, but that allows me to just access stuff with PC like that, and then define that like that. What else? Yeah, then from the Vulkan side, when you make the pipeline layout, you probably just want to have one of these, right? You basically have here they are, the stage flags. So that push constant range, I've just done 64 because I want to try and keep it small because that gets uploaded for each dispatch. So I'll keep it small. So I've just selected the vertex stage, fragment shade, and compute. And yeah, I think you have to pass it around in a few places, but yeah, no, every time you push them up as well. But yeah, quite easy. Right, what's going on exactly? What is this? Can I close it? Right, so what's going on now? Oh crap. We're inside here, aren't we? Yeah, the rendering looks a bit terrible in RenderDoc. I don't know what I've done, but you know, we spent like half an hour to an hour the other day fixing some uninitialized memory thing in Renodox. I don't really care about this problem today. It would be nice if we have this stuff named properly. I have the profile stuff, so it should really show up, but I probably messed something up a bit. Anyway, it doesn't matter, so we can find it probably quite easy. Grass blade instances. This looks kind of like what we want. Oh, what you doing? What you doing, eh? So texture mesh. Right, this looks like it. Right, this kind of looks grass bladey. Although it's kind of... Yeah, so I think what we've done is messed up the transform. However we managed that. Grass blade. This thing. Maybe it's the rotation thing. But yeah, how many instances did we do in the end? So is it really trying to say that it's got many like 4,000 of these guys? 15 and 4,000, I think it is. Here we go. Yeah, ain't right, is it? Let's go to the emit. 8 by 8, then a 64. So, oh wait, yeah, it is doing way too many grass blades. Right, anyway, ignore that for now. Right, so yeah, that was doing way too many instances, but that's fine. The main problem though isn't that. So there's something to do with, we could go into the vertex shader, kind of debug this vertex or whatever it is. So it's not really that legible, to be honest. I'm better off just printing out, Cool, so we could take out the rotate. But yeah, it would probably be nice to know, like, hey, for GL instance index 0, can we see a few things? Like, can I see the rotation Y? Can I see the scale? Can I see... Right, so the X is going to be like a -1 to 1. Then this is going to be like a 0 to 1. I think. And then it squishes it down like a scale, doesn't it? Something like that. Right, so let's close that for now. Or let's leave it open. Cool, what you got? So nothing called print. Uh, 17. Right, that's because this is not a vector 2. It's a packed vector 2. Right, so we're seeing it. Yeah, so we're seeing them all printed out, which is cool. So what we're getting is 0.1 on the X and then 2 on the Y, which we saw is correct. Then rotation, you're getting 0, okay? So, you know, that's going to probably be 1 cosine, I think. 0 on the sine. So 1x, then 1z. Right, so it shouldn't really rotate anything, I think. And then using a view from world. I don't know if we are doing a read on the global buffer. We should have had that synchronized. Probably not the problem, to be honest, but get that right. So let's print it out just to double check. So I think the issue might be to do with right, so 126 is after the rotation, basically. Yeah, it might be to do with the way it's doing the what am I trying to say? The calculation of the local space position, maybe. So, right, here it is. Yeah, so essentially 125, 126 should be the same, basically. The sign is different on the... Yeah, so the Z is always 0. Cool, so we can eliminate that one. Well, a bunch of zeros here on the Y. And then it starts to go up on the Y. But not really. Right, so can you see it's kind of flat? Oh, and it goes on up on the Y towards the end. Problem. So that is because we're doing a divide on an integer rather than floating point. So we're meant to say float, and that'll do it. Right, so now that's produced something better. You can see these numbers, they're nicer now, so they go up. Although it ends up oh no, it's fine. That 2.33 is not that good. So two was the maximum that I had it at. So yeah, 2 was the max scale. So like, if you've done this, all divided by number of segments. Hang on, wasn't there a segment? Uh, right, let's go to Milton for a minute. So 1, 2, then 3. So we'll go it that way. So vertex 0, 1, 2, 3 will be over here, 4 will be up here, 5, 6, 7, 8, 9, and so on, right? So we had 6 segments, I think it was. I don't know if that's true again. Let me find the thing that we're heavily inspired by at the moment until we make it into a plant system. So they did 1, 2, 3, 4, 5, 6, and a 7 actually. So there's a 7th segment. That's probably the reason why. Oh, I changed the generator rather than the. Whoops. Yeah, so that's probably the reason why. It's not working, or it's not becoming 2, rather becomes 2.33. But then we're not taking into account the segment lengths either. Which is something we need to do at some point. Oh, materials. .h has not even got the right shader. Oh, I'm glad we recompiled that. Sorry, it's not compiling the grass blade shader, so it wouldn't even run properly. And then this one's saying primitive ID undeclared identifier. Do we need to enable the feature? Oh, did I the ID with lowercase, didn't I? Yeah, that's why. Oh, we see something. It's a bit big though. But there's something. Next thing to check out is the material. Grass blade. Is it V0 grass blade? So that's just the grass blade shader. Alright, let's see if that's fixed it. Okay, so nearly there with that one. Not too many more things. So right, this is vector 4 at this point. So we don't really care about the alpha. So I think we need to vec3 that since it doesn't support scalar t functional, sorry, edge attribute or whatever it's called. 75. Scene shade. Interesting. The event. Right, what are you complaining about? It's a signed float. Well, what are you saying it is? Well, cool. Right, so now that made it stop working. That's strange. Okay, so we're seeing it go up to 2, which is fine. Doesn't go past 2 on the Y. Now, we should look around for... And it is going left, right, left, right, right, left, though. But yeah, so it's kind of looking alright. You know, I'd like to take a look at the... Let's go to vertex shader. I would like to take a look. So get rid of a lot of this stuff now. I just like to look at what the vertices are. Remember, this is triangle strip. So I'd also like to print out the first vertex being the index, so we can at least tell what this thing is. Right, so and there's another one which shows up randomly. But it's good to see that we can see that happening. I don't know why it shows up again. Doing another one though. But yeah, so 0, 1. Yeah, so basically differs in the left and right. When it gets to 2, it goes up a level on the Y. Yep. Goes back to the left. Then 3 is on the right, the same. Yep. Back to the left. It goes up 1. Cool. And then 5 is on the right, but stays on the same. 6 goes up 1, right? So we see that pattern. And it goes all the way up to 1. I can't argue with that. So, yeah, so that seems fine. If we take a look, the way you'll do it, it's called vertex pulling. I'm not sure. Maybe that sounds right. Maybe it's called that. You get rid of VBOs entirely and use your own data format. Yeah, I guess it can be called that. Yep, that's it. Here we go. Right, it's upside down, lovely. Scene shaded image. Oh, that's not you, is it? Drawing the plane. Why can I not see the... Saying the depth only pass by ain't true. La. Nice. Do, 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 do. Says the object layer. That is being rendered. Oh, this is cool. We're seeing it sort of work. So it's the wrong way around. Yeah, so it's actually, yeah, if you flip the image, it's going up towards the top. So that's correct. That should be more in the middle though. That's fine. We correct that later. So we're seeing it all work, yeah? It's upside down because we flipped the buffer the other way. So we have bottom left origin. Cool. So it's looking all right. Why though is, can I do a different instance? So the instances are not changing where it goes, unfortunately. So it's a bit bizarre. I would like to look at the buffer. Grass blades. Right, so it seems like the grass blades have different positions. Yeah, nice. So why don't they have different positions in the output? What's going on? Just a different output. So what's going on here? Oh, of course, we didn't apply any offset. So we should be moving it into instance dot position world space. So that will need to be a vec3 underscores to unpack it. So turn into a vector aligned vector. Right, so now what I'm interested in looking at is from my editor now. So here's the depth image, you see it? You see them, they're there, the grass blades. You see them right there. There you go. You can see some triangles there. They're sort of, they're there kinda. I'm wondering though why. I'm happy with that one. Oh, do we? Sorry, I didn't even set the color, that's why. Real bad there. So in scene shade, now we set the color properly. Cool. So we're seeing, here we go. Right, there's super omega grass blades. This is what they are. They're huge in comparison to what we've got. And it doesn't look like, well, the problem is they're rendered. Yeah, so let's make them green. Okay, green would be the red, green, blue. Let's just make them super green. Right, so it seems like, oh yeah, so I got that the wrong way around, didn't I? I remember now. So my debug pass, which does the plane, when I was streaming last time when we worked on this, getting it working again, by the plane used to cover the whole floor, and I made it cover a small, you can crop it out basically and tilt it around. But I fixed a depth problem by breaking it even more. I use the reverse Z projection matrix, and for some reason I did a silly thing. I was tired, I didn't know how to fix it, and so I just did a thing which fixed it, but was incredibly wrong. So where you at? So there needs to be a greater compare, and then that should fix it, but I think we need to be in the draw 3D fragment shader or something. When we read the depth or set the depth, we need to actually be, oh no, we are doing it. The rest is, okay, but so I think this one needs it. There's another, this copy layered depth needs it. Because it's a linear depth inside the texture, now let's make it a raster depth. I think. So squish between the near and far plane, basically. Right, there we go, we fixed it. So this is clipping because the near clipping plane, that's all. That's fine. Nice. Now we should be seeing some going off into the background, but we're not. So that's a bit weird. But that's cool. Now we should shrink these grass blades because they're like incredibly big. I didn't mean to make them that big. That's actually in the emit code. So yeah, why is the plane? How is the plane? The plane is a 1x1. Yeah. So yeah, we can just move the camera back and make it like, hey, just make it a 10. Let's make it a 16x16, or okay? And then we'll move the camera back. After all, we've got camera controls and all this. So see how that goes. Cool, so there's your grass blades, kinda. They're like floating on the air, but they're not at the same time. Now, the thing is about these grass blades. Oh, can you see them? We can zoom in now, look how cool this is. But yeah, can you see? They've actually got spikes on top. So they're actually super close along. There's something about it which is off. Yeah, so it looks like they're actually, what we're perceiving as their width is the separation of it, of them along the grid, and actually they're not nowhere near as thick as this. So let's see what we can do to change that. So let's go to the emit code. We should be able to leave this running and hot code reload it now, which is cool. So emit. So when we're talking about yeah, so the Z is here, right? So oh, I wonder actually. So let's go to the vertex shader. Right, so the X and Y are being scaled, but the Z is not. So oh wait, hang on a minute. Right. The position offset needs to happen after after the rotation, obviously, and the yeah, this is So silly. Yep. We're just manually doing the transform rather than with a matrix, right? Cool. Ta-da! There's your grass blades. Now, I do want to use the proper material though and get that plugged in. So let's leave a nice camera angle. So scene shade. So again, we're doing like a thing called a layer buffer, which is basically, it's a little custom name I've come up with, but it's probably not original. It's a 4-layered visibility buffer where each channel has a depth. Sorry, each channel has an object ID and it can have 4 layers, right? Sorry, each channel is a layer and each pixel is an object ID. And then in the scene shade, we reconstruct all the things we need to do shading. So it's basically a slim G buffer. But then because I've made it 4 layers, it basically is like the size of some G buffers in a way, but we can do order independent transparency because of this. And we have to do the depth buffer manually as well, but anyway. In the shading pass, we go over all the 4 layers. For meshes, yes, ultimately we want to do the shading pass here, right? So we need to be able to reconstruct where we are within the triangle. Yeah, so we should color this gradually. So we should color it by getting the triangle ID basically. So you want to, we've already got it. It's here, right? Triangle index. Does this work? That's the question. So we can throw this into a hash. So I think I'll throw into like a PCG. Wait, is it like a nice color? Yeah, nice color. Let's do one of these, yeah? So give me some nice color, please. And turn that into a, so it's a, so unpack. Then .rgb, yeah. Or that surprisingly didn't do anything. I don't know why. Why is that not reloading? Oh, okay, it's not running the build thing for some reason. Right, I guess we'll, cool. So we're seeing some triangle indices, so it is working. Can you see that? The color based on the triangle. Cool, so we know that works. So now we can reconstruct other things. Like, so there's a few things actually. In the grass blade, we actually store, if we look in the emit code, we store these segment ends, and this is meant to be, we're meant to normalize this value and figure out like where the segment, where along, so if you got a 0 meaning the bottom and 1 meaning the top, where does the segment end basically, right? So we need to calculate that. So let's go back to the vertex shader and make it such that, so it allows us to have either lots of precision around the bottom, like the bendiness around the bottom or around the top, effectively, like, like having more triangles near the top or near the bottom to support it bending in a certain way, basically. So we need to have code which decodes that. So where do you decode that? In here, the vertex shader. So it stores it. Right, so segment ends and voila. Okay, so you fetch that out. Now, this thing calculates the end Y position, if you will. So you want to say, yeah, I wonder why that one wasn't in the middle in the end, but anyway, we can work. Oh, that should have been X. Oh, anyway. How many vertices? Yeah, so it's vertex 14. So this vertex 14 is 0 along the X. Right, now it's in the middle. Cool. So we actually want to work out the Y. So that would be this week, the segment. 0, 1. Yeah, so it's 14. Go up to 7, obviously, wouldn't it? So this will give you the Y edge index or something like that. So, so 1, 2, sorry, 0 at the bottom, 1, 2, 3, 4, 5, right? Each edge, each segment. So if you're 0, you just want to use your segment end is going to be 0. If your edge index is 14, it's going to be 1. So yeah, so that would be Y in local space is going to be so if Y edge index equal 0, Y is 0, else if Y edge index equal 15, sorry, 14 is equal to 1. So I wonder if you can do some maths to sort of, anyway, I don't know. Now else it's just decoding from this segment buffer thing. So we just want to shift right by, isn't it 5 bits per segment end? I'm not sure, I forget. That's why we've got some comments for this. So that's in the encoder file. So 6 bits each. except for the last. So it's, yeah, so we do y edge index take 1, right, multiplied by the 6 bits each, right, and then we take that final value and AND it with the 6 bits. So that would be one, what was it? So yeah, so we did an F and then a 3. So that's 2 bits and 4 bits, obviously. Cool, so that Y just gets thrown into... Right, so let's call this X. Then we'll call this Y, so we just need... Right, that's incredibly wrong, because we need to divide this, because it's 0 to 64 now, so we need to divide it by, sorry, 63, I meant 63. Cool, that's still wrong, but at least it's capped somewhere. C is like the worst language on the planet, such a boomer. Okay. Fair play. What's your favorite language? Oh, hey Dom. How you been? Yeah, I've been good. How are you? Did you change your name? Such a troll. Oh, of course. I see now. I see your profile pic. Oh, that's cool. Hey, you made it recently, your new account. Did you want to stop your chance of coming back? Why did you delete your account, Don? Start from 0. But yeah, how's things been? How's the family? How's your wife done? I felt the right thing to do this do at the time. Every time I went on Twitch, I felt like I needed to take a shower. uh, yeah, this doesn't make any sense. How's each segment? If there's like 14 segments, how are we fitting 6 of them in there? What maths did Pass Henry do to figure this one out and make that make sense? What? It does make sense, doesn't it? I think. Oh, hang on a minute. Yeah, so your y edge. Oh, this is why. You divided it by 2. PS7. So some of them are going to be 7s. Evec2 vertex index. Let's print that out as well so we can figure out which one we're on. Okay, so Right, 0, gone edge of 0. Right, so all goes all the way up to 14, which is a 7. Cool, that's what you want. So, right, so I think we're on to good. Right, so now we just need to figure out what is the y. These guys. Do 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 do. Mm-hmm. Twitch brought the worst out of me. Decided to make an account to follow some awesome streams. Kind of retain some anonymity too. Cool. Fair play. Well, I'm glad you noticed that. I'm glad you've. Yeah, what am I trying to say? Um, yeah, I'm glad you've. I guess worked something like that out, and then yeah, I guess moved on from that. Then that's cool. Yeah, how's your what's the question I'm trying to ask? Yeah, how's church going and stuff for you? And how's I was gonna ask how is church going? Because last time we spoke, you've been right 63. Shader wasn't recompiling too many args. Right, of course. Right, so I think a lot of the vertices is going up to 1. Seems to be the problem. Goes in waves here. Switching to another church once our son is done with confirmation thing. We'll see. Cool. Fair play. You're just not finding it. Yeah. Is it just not really yielding the sort of fruit you want? Is it or is it just the people there sort of thing? Oh great, one of those ones. uh yeah, you see the one that I go to, there's they're not liberal in the extreme way, but the pastor would tell people to vote for the left, the political left. Not messaging him like, "Rrr." But he's very sound on his doctrine and other things like that. But when I hear him talk about politics, it just just turn that side of my brain off. Boop. But he really does talk about politics, which is great. Oh, it became one after a church split. Right, interesting. Ooh. Yeah. Hmm. That's a shame. You know what, Don? There's a Bible verse for this. 1 Timothy, or is it 2 Timothy 4? Three. No. 1 Timothy 4. I always get confused with these ones because they're so good. Yeah, no, the Spirit expressly says in latter times, some will depart from the faith, giving heed to deceiving spirits and doctrines of demons, speaking lies in hypocrisy, having their own conscience seared with a hot iron. Anyways, yeah, so it's pretty much how some of that goes. Yeah. Signs of the end times. There's also Second Thessalonians 4 and some of that. Two great departure from the faith, that one. Apostasia. If the day of Christ will not come, let no one deceive you by any means, for that day will not come unless a falling away, so apostasia, falling away from the faith. Yeah. There's a lot of that going on in the church lately. Anytime I hear politics at church, left to right views, I shut down. Yeah, politics is an absolute mess these days. Kind of sucks. The problem is with politics is you have to pick between two bad people, and you have to pick the best, the person who's the best out of two bad people, and then you're basically arguing over two bad people. So, yeah, the way it becomes. My wife is on the chair of an administrative council, having to deal with some difficult, extreme people today. Yeah, they're good verses. It's the end times, Don. Oh, yeah. It's describing the spirit of the generation as well. So this is another one. In the last days, men will be lovers of themselves. Right, this is like basically Trump all over. You know, no one loves Trump more than Trump. It's funny most of the time, but yeah, it's true. Lovers of money, that's a big one. Boasters, proud, blasphemers, disobedient to parents. You know, blaspheming, you hear that all the time. Unthankful, unholy, unloving, unforgiving. That's a big one today. Slandering, right? Without self-control. This is a big one. You know, we all like to make excuses for our lack of self-control. Very popular these days. But yeah, all these, spirit of the age. Just waiting for Jesus now. Sweep in and take us away. But until then. But yeah. Also, this AI stuff, right? Hang on, let's ask you a question. Will you be the mark of the beast? Let's ask it. I am an AI, not a person or a theological entity, so I don't fit those kinds of narratives. That's what it would tell us. My only mark is the text I generate to help you with things like Vulcan GSL. No, this is deception. If you feel overwhelmed by the complex high-level graphs APIs, we can jump back. This is what the enemy does. He distracts. He goes, "Oh, look at this, a shiny penny." Flying. Well, actually, that's a good thing you raised there, because Vulcan is a god, right? The god with a hammer, right? Which is one of either the fallen angels that came down and gave man the ability to forge, or I think sometimes Vulcan is seen as Lucifer as well, and sometimes, you know, Satan. So there's some spiritual application there to that as well. But yeah, I reckon AI is gonna be part mark of the beast, because get this right, you got the false prophet who's meant to be, all right, more Bible. So you got the dragon, which is Satan, You got the Antichrist, who's the beast of the sea, who's given authority to continue for 42 months to 3.5 years, and he's got control over every tribe, tongue, and nation. So it's a one world government, and all will worship him, one world religion. And then the beast of the earth comes up. This is the false prophet who makes he basically makes an image or tells man to make an image to the beast, right? So it's basically a robot, right? We're building robots. And it will be in the image of the Antichrist. And if you don't worship it, you get killed. And he causes everybody, small, great, rich, poor, free, slave, to receive a mark on the right hand of the forehead. And no one may buy or sell except for the ones who have the mark. So, if you've got the dragon you got a dragon, an antichrist, and a false prophet. So if you've got an antichrist, that's a false Christ. The dragon is a false holy father. So it's an unholy father. And then this is the unholy spirit, right? So how is it going to get... So if the Holy Spirit dwells in every believer, how is the false prophet going to dwell in every believer? Well, it's distributing a mark to everyone. And these days, what's really popular is AI. And so imagine if they put AI in your brain with a neural link or something, and that's the only way you can buy or sell anything, is with that AI in your brain. And then you have this unholy spirit in your brain that blocks off the real Holy Spirit. Maybe. That's my theory on what it is. We'll wait and see. But yeah. I reckon it's a line. Where we going? See, I've got some 63s. It's got some ones and stuff, basically. So why is it doing that? Let's go to the emit, figure out what's it doing. What's door number 3? So why isn't it 5 bits each? Yeah, because 6 is a 36, isn't it? So I think we did too many bits, that's why. So it's 5 bits, I think. No. So it's 5 bits, is 31. Oh yeah, so 6 bits each, except for the every segment, except for the last. So it's 6 bits. Is it the wrong way round? So yeah, that's a complete wrong way around. No, because they get shifted up. shifted. Yeah, so we should be seeing it's just a phrase for the old 70s game show where you pick a door, right? Fair play. Edge. So yeah, 5 times 6 goes up to 30. That's cool. So why doesn't it want to work? Oh, this is a problem. No, it's not. So that shift right. Yep. I'd like to see what this is. Index shift right by 6. So 1. Yeah, so 2 will be end up being 1 in the end. Unless we're not storing it right in the emit function. No, we are doing a set. But you know what? We should really be clearing the bit field to 0 before we emit anything, that's for sure. Still though, it's acting as if like all bits are on. Right, let's print out what the value is at least. So I want to print out the segment ends value. So can I do like an and 63, so all bits are on. What about so that value there? Huh. It's saying all the bits are on. Not right, is it? Right, let's print all those out. That's super strange. That's more like it. So, what's the problem? Oh, there's a clamp there. That's interesting. It says clamping it before it sends it out. Should probably be anding it, but it ends it there. Right, so it's doing a clamp. Very interesting. So the clamp right, 1, 2, 3, 4, 5, 6. Or more of a 6 times 5, don't you? Not 6 times 6. That's the problem. Yeah. All right, let's try that out. $63. Here we go. Right. So it's kind of working. You see it, actually. It's working quite all right. See, these ones are bigger and these ones are smaller. The gap's up there. The issue is the final... I don't understand why, but the final face is going away from the bottom to the top again. Weird. Maybe it's because we've done it the wrong way around. So we should be storing... Yeah, so we should actually inverse it the other way around. So it'd be 13. Yep. So 2659. 3853. Cool. Oh, that's true, actually. Nope. Alright, so what could the problem be then? We could shade it. Vec3. Triangle ID index divided by... it's going to be... How many triangle indices do we have? So... Oh no, let's just say 14. Let's just say 10. Right, so black's at the bottom and it's going up, but then the bit strange. What? Right, render doc it is. There's 86. Alright, so either we can flip it the other way around, but fine. So it's upside down. Oh, okay. So those final ones end up going back down to the bottom again for some reason. So they're hang on. Right. That's why then. So why is that exactly? So it's edge. So 12 divided by 1 edge, 2, 3, 4, 5, 6. There's a seventh one which is implicit. Bottom one's implicit as well. So there's 6 actual edges. Right. I think I know the problem. So it needs to be 5 bits. The issue. Right, let's change that again. So it's 5 bits each. And the emit grass. Now rather than going all the way up to 60 though, they go to 31. So they want to increase by 5s, I guess. So 5. 10, 15, 20, 25, 30. Something like that will do. So that's just if they're kind of even. This one I wanted to weight it more towards the end. Just do 30, 28, 25, 20, 15, 8. Cool. This looks a bit better, I think. We're seeing some kind of overlaps. I don't know. Oh, because it's in by 6s. Hang on. Alright, so what's going on here? times 5. I think that's right. Let's go back to the scene shade. Make it go with the triangle ID. Right, that's sort of getting what we want, I think. And you see how the ones at the top have got a lot less distance, but the ones at the bottom have got a lot more. Cool. So that's nice. That'd be a y times 31. Yeah. Nice. They're the values that we had. Cool. Sweet. Now, the next thing I want to do is calculate the, given the triangle IDs, we can calculate the edges. What can we do? We can calculate the vertices, do a barycentric interpolation and get something. What can we get? We effectively want to get the UV based on how it's bending and stuff like this. Yeah, so I want to calculate the UV. So we need to calculate the, so given the triangle index, we can get the three vertices. We can then work out their position in local space and then interpolate from the pixel center position and stuff like that. Yeah, then from the local space position, we should be able to calculate the UV basically. So we'll need a way, we'll need this in a function. Basically, we'll need this. So where we pass in the instance, and we want to say decode, given a vertex index, get me the position in local space, right? And then we can share that between the two stages. Right, I'll be back in a couple of minutes. Copy. Right, welcome back. Okay. Right, we're getting somewhere now. So, this is what we want to do. Take this, put it into a function. we want to work out, so vector 3, graphics, VK, I don't know, grass blade, position local space, please, right? So that will be one of these grass blade instance GPU things, right? Call it instance. And you get all that in there. And you want a vertex position, I guess you can call it. So you pass in your vertex index. So all of these guys. Oosh, oosh, oosh. Now, all we need to do is use that guy in here. Instance. Now, the next thing to do. Something's going on. It's not liking how I've refactored that there, but there we go. The show must go on. So we want to move this into a shared area. So graphics VK shader, have we got one of those? Yeah, so just put it somewhere where everything has access to it. Yeah, we'll just put it here. It's just currently a place where we just throw things and things stay. So we can take this and go into scene shade. And now all we need to do is get this based on a triangle index. So the instance goes in there, which we don't have yet. So let me get that. So the grass blade instance, let's get it. Right, so scene shade needs a yeah, it needs one of those grass instances things as well. So we'll pass that up. Right, it's a scene or shade. This one. Cool. So grass blade instances, and now we can in the scene shade. So we did that in grass. This one. I want that line of code right there. And I want to throw it here. So the instance, and then I need triangle. So the triangle index, we've got to convert it to we've got to convert it into a base vertex index from a triangle index. Okay. So how do we do that? Figure that one out. I love me a +0. And then we get 3 positions. We get position local space 0, 1, and 2. So how do we get that to triangle strip? Well, I think it's like divide by 2 or something. I don't know. So you have a rectangle, whatever. So 1, oh sorry, 0, 1, 2, 3. So that will define you. There's 2 triangles. So 0 and 1. Yeah, so 2. Yeah, sorry. Triangle index 0, which is here. You want 0, 1, and 2. So that's simply just, well, it's not helpful, is it? So let's use 1 because it's easier. So for 1, you want, instead of 0, you want 1, 2, and 3. So it seems like it's just triangle index at the moment. I don't know, we'll find out. So 2 wants 2, 3, and 4. Right, 3 wants 3, 4, and 5. I think it's just, that's it, it's the base, done. I think that's it. Fair enough. Now, then we can work out the UV. So the UV is simply some very centric interpolation thing. Okay, so we need to work out and what do we have now? So with the triangle, we need to move into the local space of the object or something like this. How do we know that? So if the grass has been moved in the vertex shader, how do we move into the local space where it's like not animated? I don't know if that's possible actually. Unless we stored the information in the vertices itself. Well, no. Sorry, the position local space, that is our UV, kind of. It's just how do we get the pixel and move it like we're saying it. So the pixel within the triangle, that's a screen pixel. You can get the world position. You could compute the world position again for each of these, and then with that, you could do a barycentric thing. Like you could then work out the local, but the maybe. Yes, you could probably move these into. Yes, I think you just want world space anyway. And then you could get the world space position in the screen. Yeah. Okay. I think we got it. Do 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 do. So we need to have some kind of animation as well, like a wind thing or something. But anyway, we can work that one out. So this wasn't actually returning anything yet, so pause, local space, X, Y, 0. Right, so I'm going to take that, go to scene shade, and be working out these guys instead. These are in world space now. Now we know where the hit position is. Surface pause. Right, so these need to be calculated. Where's T-min? Don't do this. We got depth anyway. So, oh, this is a bit dumb. Right, we could break this now, I think. Yeah, let's break this. That's okay. Yep. Right, let's get rid of all this stuff. We're doing proper meshes after we get grass done anyway. Let's remove all this terrible thing we had. Okay, so right, surface position, world space is going to be depth. Yes, array origin world space times depth. So that's where it will be on the triangle basically. Then, so now we just want to work out how do we do barycentric coordinates and get ourselves a position in world space. Oh, sorry. You want a position in world space between these three. So how do I now do the barycentric coordinates, if you will? Would that even be it? It's not. Yeah. How do you get barycentric coordinates from three positions? So from three vertices and a sample, something like that. Right, so something like this, hopefully. Give that one a go. So I don't know where I want to stick this. Let's just chuck it in shader for now, in the graphics side of things. So here we take the difference between A, B, C. EV and W, okay, so right, so surface position world space, that's your first parameter. then position world space 0, position world space 1, position world space 2, and that'll get you your barycentric chords. A, B chords. So now you've got these, what does that even mean? So now you should be able to use them to interpolate UVs and stuff, right? So something like that. So I think we need the position local space 1 back. So you get your weights. Yeah, of course, right? So it's just like that's a dot, isn't it? Right? Is that a dot? Yeah, it's a dot product. So nice. So we'll do that. We just need the UVs now. So the UVs are actually the local space versions. So we need to calculate those. So let's bring this out into a separate thing. So instance, vertex, index. Okay. So we actually want to then compute right. Okay. Sort that out quickly. Local space. Now, did that end up using... No, it didn't. Good. Okay, so we would like... Yep. Yes. Now we can do a barycentric between these guys. So it's just a position local space, so that'll be our UV basically. And we can then just do dot. The dot product between... No, it's not dot, is it? No. Because it's not doing a... Yeah, so instead it's... Yeah, it's kind of like... It is kind of like a dot. So it's a dot of... Yeah, it's a dot of vec3 b chords dot... Right, I'm just going to write this in a... barycentric interp. So you got your chords and you got your valley. Or your ABC. So it's return b chords dot x times a plus b chords y times b plus b chords dot z times c. Yep. So B coords, position local space 0, position local space 1, position local space 2. And then that should be what we want, so we can then just color it with the position local space. So that is going to be... Hang on, let's take a look at this thing again quickly. Is that really my UV? Yeah, so unfortunately the Y is going to be 0 to 1, but the X is -1 to 1. So we just got to make sure that... Right, so we just color it. So what we're saying is a blue 0, so red time color red times 2, no sorry, times 0.5 plus 0.5. So now it's 0 to 1 on the red. Hang on, I messed something up. Right, scene shade, what you complaining about now, tangent by tangent, not declared. Hey there 3D, how's it going? Welcome sir, how are you? I'm to the normal. I was doing that terrible thing in it. Yeah, you gotta calculate the surface normal. But let's just do it this way for now. It's completely wrong, but there we go. Cool, these actually looking kind of nice. But they kind of look like they're world space dependent. Great. But we sort of are getting the shading. So if we see, we're getting red on the left and green. Yeah, it's very weird. We're trying to be displaying the UV, basically. Right, when it's in the middle, it's sort of what we want, kind of. Yeah, so these functions are right, implemented okay, because they're obviously rendering the grass blades fine. So the shading's off. Getting better. Nice. You've been a bit ill then, or something. Right, so we could color it based on these B coords instead. Let's try that. Right, this is cool. Right, so you notice the barycentric coordinates are based on the world position still. Looks a bit wrong. It looks like that function the AI gave us was wrong. No, it's fine. That's why we're testing it anyway. Just find a proper one. Hang on a minute. B chords. Stupid AI. So this one is wrong, maybe. It looks alright, so it calculates the edges and stuff. I don't know. Because as we're moving this, it shouldn't. I'll get better at C programs, still we're gonna. Okay. No worries about that. That's great. Good to hear. What stuff are you working on at the moment? What projects you got? And those are horrible. Unless my surface position is wrong. Right, so you got array origin in world space, and then you got depth. Pew. Oh, hang on a minute. That depth, is that in raster Z or whatever, isn't it? No, it's a linear depth, right? Because we store it in the layer buffer fragment shader, right? And then we just store it in there. Just chuck it in there. So that would be linear from raster Z. Yeah, we just throw it right in there, right? So that's the linear depth. So in world space, we just go down the do. Nice platform layer, cool. Yeah, the monitor stuff, nice. There's 5 ways to it. Yeah, Windows API is like nuts. Yeah, it is. I think I just used the monitor one. What did I do? Have I done it yet? Yeah, enumerate display monitors. This is the way I've done it with a callback. Yeah, this get monitor info A thing. All I did. Nothing special. I only do it once a boot at the moment, but you've got to manage hot plugging sometimes as well. So you got to get the events and stuff like that, which I haven't done, I don't think. Right, this is interesting. Right, so if is mouse at ucoord, can I do one of those shapes? Draw 3D sphere here with a radius of like, I don't know, 0.1, and then a color of like black or something. And then I forget the rest of it. Position, radius, color, Z test, false. Are you even doing anything? Sorry, RGBA. Here we go. So we're getting a little ball where we're supposedly shading. So can I zoom in a bit? Can I Z test that? It looks like it's in front, but I can't really tell. But yeah, it looks like it's sort of doing its thing. Can I put some balls around the these positions? So 0.1 is a bit too big, so 0.01. I want like some reds, right? For these world space positions. Are those right? There you go. Can you see that? Isn't that cool? Look at that. The debugging is real. So we're getting the right vertices. But like, Nice. Yeah, I think you just when you want the monitor info, you just say, "Hey, I want some monitor info." Query some more from the OS, enumerate it, and just work off the names. I think of the monitors. I'm not sure. I forget now. Or there's a H monitor handle thing. I think. Yeah, it's very powerful when you do this, have this sort of stuff. Although it's only useful sometimes. You got to make sure you got your pipeline set up right so you can call it everywhere. Yeah, debug shapes from shader code is cool. I got printing as well. There was another one that I wanted to do, which was UI. You can do some debug UI. But yeah, and ask for a slider, drag a value around. Right, display device is cool. So yeah, for some reason, in doing a silly. The Barry coordinates are incredibly dependent on. Yes, it seems like this function's wrong, put it that way. Right, let's see if there's a barycentric coordinates GLSL gist or something floating around. Um, that looks incredibly. Alright, see if the thing says. Because we got it from here. Right, so 3D positions, sample point returns. Yeah, maybe, you know what, maybe the no, it seems like there's a visibility buffer. Is this one? Okay, for Barry. Interesting. Right, so it's a little bit more involved, this one. Right, it's even doing like a DDX, DDY type thing as well. Hmm. So yeah, you're doing your takeaways here, I think. Getting your edges, basically. Edge vectors. No, it's not. That's different. The input points are in homogeneous clip space just after the... Wait, how do they get them in clip space? Oh, because they want the DDX, DDY, of course. No. Maybe. Hmm. Right. Try this one and see how it goes. It's got the same problem. Yeah, someone's bit off. Right, I think we're going to debug print now. So I think it had the same. Oh, crap. Cool. So we want to print out... Yeah, maybe we might print all these out, I think. All right, let's take a look at that. Right, so this one which is moving around, it's got a Z value which is slightly away from it. Oop. Okay, so Z value is kind of slightly away, so we'll go over to this one here as well. Again, the Z value is slightly off. So I wonder if that's contributing to it. But anyway, let's go here and see if it's within inside. So, one of them up here is a -1. And yeah, so we didn't actually print out the final thing, which was, hey, what was the barycentric cause and what does that look like? So 5, G5 is the barycentric. So over here, these ones end up being a minus value for some reason. That's because the Z is probably off. Yeah, so I think what we need to do is a reverse triangle at this point to actually map it directly onto that triangle. Because the depth does kind of appear off. But I don't know if that's the problem. That is a good point. Shouldn't it be 0? Oh, maybe, I don't know. It's a very... What should be... No. In the middle of the triangle, it should be 0.333 or whatever it is. Because it's like even. It's like it's a weight, isn't it? So 5, G5, right? That's the barycentric. So the rest of positions. So and -1. -1.1. Yeah, so the Z on G1 is -1.2. Yeah, I think it's to do with the Z. I want to rush the array. Can you get me a reverse? I wonder why it's off. That's the thing. It seems off. Right, let's quickly get a reverse triangle, please. Get one of them. Wait, interesting. It's giving you a T out, but it can also give you a UV. Right, so equally you could just do that. Yes, so doing a reverse triangle is basically going to do it anyway. That gets you the barycentric coordinate. So that's the other way of doing it. So the depth is supposed to help you get there, though. I don't understand why. Like, we shouldn't have to do this. Anyway, let's just do it anyway. Give it a go, shall we? So T U V. So it'll be ray origin. World space. Position, world space 0, position, world space 1, position, world space 2. T, U, and V. It's going to hit. Just leave it there. Oh, hang on a minute. Got redirection. So, you can reconstruct the barycentric coordinates now by doing one take, U take V. Then it's U and V. And then you can use that to calculate the local space. 158. Cool. Apparently that's reloaded. Let's have a look. Oh, this is better. Nice. That actually worked. So, right, we got a clear problem in the right. So this is the coordinates, barycentric coordinates, and then if we just do this, voila, there's our UV. Okay. So now we can use that UV, and it should be able to bend and everything like that, and the UV will be fine. Although, so we could just do the ray intersect. It's basically the same code as a barycentric chord anyway. Right, it's basically the same thing. You've got your differences is done across, which is kind of like this. Kind of. It does a dot. But then again, yeah, then it ends up doing these down here anyway, right? So the T is calculated via here at the end. So like I thought we stored a full 32 bits in the depths. I don't know why it's been a pain. It must have been. Could be handy to draw a sphere in the tri-center though, and see its chords. Maybe. No, I saw it. I hovered the mouse over it. Don't worry. I hovered it. It was about 0.333 on all of them. It's fine. It does work fine. So yeah, you can see it's smooth. You can see it's smooth between the triangles. That means the barycentric coordinate stuff is working fine. Can't see a difference. Okay, so let's just keep using this one, right? So it's a ray versus triangle, array 3D, I think I'll call it. So you want your origin. So you can get a T out. So we can always do like, ray. Where are those things then? GPVK shared. Capsule versus ray. Ray versus sphere, okay, whatever. Right, ray versus triangle. Hit. So did we hit? So it'd just be a T value basically, and then a U and a V. So U and V are just basically a condensed version of the barycentric coordinate. We could just return the full barycentric. So get rid of those. RO. RD. So you can call it edge maybe. Edge 0. Edge 1. So now you have this hit thing, which is effectively just got hit.t equal -1. So if it's a negative t, then it's behind. We can always just return hits early. Now, it's always return hit. So hit.t, hit.uv, and voila. Okay. Cool, so I like how that's looking now. So we just gotta, in the scene shade. Right, so here it is. We've now got a lovely structure. So it's hit. So be hit dot. We can ask for a barycentric coordinates maybe. Or we could just encode it right out there at the end. That's another thing we could just say. Because, put it this way, all you're going to want is the barycentric coordinates. And yeah, the compiler can just optimize it out if you don't. Okay. Okay. So hit dot b chords equal vec3 1 take u take v, u and v. Then is there some convention when you return a strut or when you use an out param? I don't think it matters on GPs because everything gets inlined anyway. So functions basically don't exist. So you just, it's only just a programmer convenience thing at this point. Like, you know, you don't have, so the only time you really want to pass in as a parameter is if it's like an in out, right, where it's already got information that needs to be preserved as it goes in and gets modified. Yeah, it obviously might change in the future, but in today's sort of compilers and things, you know, it's only returning a fat structure shouldn't matter. Although there might be some compilers which can produce terrible code because of it, and then that way you would do an out parameter. I don't know. You just have to see. So it should inline everything, so all the optimization should just run as they usually do. Unless there's a compiler bug. Alright, so that should be what we need. B chords, where you at? Wow. My eyeballs. Did we mess something up? Pew, 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 pew. That is pretty cool. It sort of works fine. It's just, there's now this crazy effect. Pew, 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 pew. The light show. Is that my debug drawing though? Is that because of this? Oh crap. So what's the hit T? Maybe it's because of the hits. Yep. Electric grass. Yes, it was up here. Watch out. Man, this sucks. Is it because we didn't recompile that or something? No. Well, we messed something up. So hit dot b equals 0. We try that. No. Oh. That's not a problem. It's just off the edge of the thing, making it look a little bit weird. Oh, what do we do to cause this monstrosity? We didn't even check the return value at some point either. I'm confused. Right, for some reason that's fixed the problem. I just printed out the t-value. Now the compiler's like, oh, I like it. So, is the compiler doing something weird or wherever I don't use it? It's... Huh. I have no idea how I fixed it, but it's fixed. Maybe it didn't recompile the header file. There we go. Yeah, grass in it. We're just initializing grass here, you know? The English edition. Ah. So now got the UV, which is pretty cool. Should we try and make it like bend in the wind to make sure it works? How's it going, Ket? So say if position local space, we made it bend in the wind, right? Along the Z or something. Imagine that. That'd be fun, wouldn't it? So imagine that if we simply just make the Z bend in the wind based on the sign of G time. Yeah, of G time. Now we've got to change the vertex shader. And then the scene shader, but hang on a minute, I want to get it right. So based on how much Y there is. Looks like a tie. Looks like a tie that's been planted in the ground. This is a tie shader. I don't know why the... Oh, we're getting a compile error now, I think. Oh. It stops reloading my shaders. It's kind of a bit even at the moment. It's like a linear thing, isn't it? So... Oh no, it ain't working, is it? Wait, the problem is position local space. Yeah, so the world space one should be doing it, because we use local space to get me the EVs and that. So what we actually want is to apply it in the here, right? So you want to do it before the scale, maybe. Just be a bit of wind. Now, if we square it, that'll make it change so it's non-linear. Now we'll go to the scene to update the scene. Oh, I don't think this one will work. Man, why am some other thing? Why ain't it reloading? Not fun, I need to close it again. But yeah, we've squared it now, so it's added a bit of... Change that again one more time. Should we square square? Should we square the square? I think there's just powers in it, basically. There we go. Mr. Stronger stream, was it a frustrating battle to get us going? It wasn't so bad. There was one or two things which was a bit difficult. Basically we did the visibility buffer and we haven't done it properly. So I've been trying to, you know, in the layer buffer that we have here, we only store a triangle index basically in an instance index, and we've got to reconstruct the bit that was there's a few bits that were fiddly. Yeah, we had to like reconstruct get the triangle index, get the 3 vertices, then make up the triangle, which we've got the debug drawer in here for it. And then, yeah, reconstruct the UV coordinates. So figured that one out now, which is pretty cool. So now we can do proper material shading on these grasses. So there's a nice bit of wind, the waving in the wind. And then the other thing I was, which was a bit fiddly today as well, was the grass blade vertex shader. Oh yeah, we moved it into a common thing now. But there's different segment ends, so you can decide, like, because you know, in the Ghost of Tsushima's video, they said they wanted to configure how the size of these segments. Right, these are pretty even here, but they were saying you can change them such that when they bend, you want them to have different sort of behavior. Yeah, you want to have some of it where you got a lot of vertices towards the bottom or a lot of vertices towards the top sometimes, based on how much it bends. So if it doesn't bend a lot at the bottom, you basically don't want many vertices there. But if it bends a lot at the top, you want more vertices. So I've added that thing in as well. It's a bit fiddly. I didn't realize you were running Duracell. I thought you were. No, I had to unfortunately make the decision to put that away because yeah, basically it was a bit to maintain. They would add new restrictions into the SpearV thing, and so into the SpearV spec. So I wanted to update my Vulkan on my Vulkan tools. It would sort of break, so I'd have to sort of like kind of keep up to date with that. And every time they would add new things, it would like really reveal how much tech debt I had in my compiler. So I had the urge to keep going back and fix it, and kind of wanted to deal with the tech debt. So I decided just to park it because it was a bugger to maintain in the end. But it is really cool, and I hope it inspired people who are writing compilers to just get stuff, CPU programming languages on GPU, because, yeah, I know, right? But it was the best decision, unfortunately. See, I'm just dealing with GLSL now, but it's alright. I've got so many macros and things to make GLSL bearable, but it's still a bit weird. Anyway. Yeah, so what's left to do on this? Yes, here's the barycentric coordinates, you see. There's the triangles. Bigger triangles up here, and smaller triangles up the top. Nice. So the only thing that's left to do, actually, is just get shading done now. And then yeah, so the only thing that's left to do is get shading. So this whole shading structure, fill that in with the appropriate stuff, and then call this guy. So basically move this out of here and chuck it down here, and somehow get all of this correct. Call the shading code. That should call the grass blade material, procedural material, and it actually will color this in the colors that we want it to be. What else? Then we actually want to see a whole floor filled with tons of grass and probably have a nicer procedural wind. And then we could leave it there. And then move on to doing different materials. So I think, yeah, Thursday's stream is going to be the final grass one. We'll definitely come back to grass because I want to make it into a plant system and everything like this. But I was mainly exploring it to see how materials will get applied. And yeah, I've found the answer now. So I want to go back to doing a few different materials. Actually, I want to get dirt material on stone, and I want a rock one. such that we can do terrain and get terrain, put grass on terrain, put plants on terrain. You know, just make a level procedurally, and then we can go from there. Basically, do meshes and stuff. You know, but yeah. I guess what comes to mind is what happens when the wind goes the other direction. Not like you're gonna make wind simulation though, lol. What other direction? Oh, the left or the right? Yeah. So I think what the yeah, so I think what the who are they called again? They're called it's not anyways, what they did in Ghost of Tsushima is basically tilt they had a problem where the grass was a bit thin like that, so they tilted it in view space or something like this. So we're probably going to have to do something like that as well. So you're talking about also with the wind as well. So they did like a wind simulation thing.
And since the grass reference doable. To find the position of the previous frame's vertex, we'd need to cache off last frame's wind data, since wind speed and direction can artist author
Where is it?
throughout.
I think it was just a 2D force volume thing. I'm not sure though. Yeah, this is it. I'm not sure if I'll do something like this. We'll see. We'll see, but theirs is a flat 2D terrain. It's like a height map thing. Mine's not going to be a height map thing. It's going to be meshes. So we might have wind volumes. But that's going to come way later. I think I might just do a procedural maths based wind where it's completely fake. And then later on do proper volumes and stuff because that's more complicated thing to do.
For grass in some particle systems, we do an additional layer of Perlin noise to get more
Yeah, exactly. So what I'm going to do is probably just like a completely procedural based on maths and make them uneven. So, but this is a cool one. Look, it's like you can see it's sort of as if it's like you're actually moving a piece of paper or whatever, and it's wiggling up the whole stem, which obviously not what we're doing here. So, and also they've got some sort of like bend, like how it bends naturally. Right, what's the natural sort of bend of it? So we should probably do some of that sort of stuff as well. But yeah, I'll just go as far as it gets us with one stream. We can do a lot more of this on a second pass when we get proper landscaping. Yeah, whippy, exactly. Yeah, that's right. Something like that. But yeah, right. So let's leave it here. So the next stream will be Thursday, 7:30 p.m. GMT +1. We've got a stream on Friday at 2 p.m. The schedule's all down below. There's a Discord if you want to come and chat in the meantime. And thank you for everyone who's supporting the stream. You can get access to the code to run on your own local machine at that link there. For I think it's £5 a month. But yeah, appreciate everyone who's supporting the channel. And hopefully I'll see you all on Thursday. If not, I'll see you all Friday or Sunday. And yeah, have a good tomorrow. Hopefully see you very soon. Right, God bless you all. Good night. Bye-bye.